Hi, everyone. So today we're going to do 2.2 multiplying and dividing rational expressions. I do still want to relate this back to what we used to do in grammar school when it came to fractions, multiplying and dividing. So let's look at this. If you remember correctly, with multiplying fractions, we would just multiply the top, multiply the bottom, and then cancel anything that they had in common. With division, if you remember correctly, we'd keep the first fraction the same, change the division to multiplication, and then flip or do the reciprocal of the second fraction. And then we multiply straight across. And that's exactly what we're going to do today. But of course, since we're doing rational expressions, that means we have some factoring to do. So let's keep in mind when we see a problem, if we feel like, oh, I have to factor first. So let's remember some of our factoring stuff. Always look for GCF, look for that difference of squares, and then your trinomial, whether you're going to use your box or your grouping, okay? Here is an example down below that we will do just together to see the division here. Okay, so first I want to notice that it is a division. Now I tend to factor first and then flip, but this example here decides to flip it first, which is totally fine. See, we keep the first one the same, change division into multiplication, and then flip the second. Then we see that we need to factor everything. And then we start canceling, and remember, cancel the groups. So those groups, it's like that brother or sister who never leaves you alone, right? Once we cancel, then whatever is in the numerator stays in the numerator. Whatever is in the denominator stays in the denominator. You do not have to multiply out, just keep it the same. So let's do some work together. So number one. Now, as you can see here, there's not really factoring. This is pretty much just multiplying straight across. So I'm going to do this a longer way. If you find a shorter way, you may do so, but I'm always going to do it the long way. Okay. So I have this 3 times 8. Now 8, I'm going to break up into 4 and 2. The reason why I know to do this is I see there's a 2 down there. So I don't really need to break up that 4 anymore. Then I see on top here, I have 2x squared and x cubed. That means I have x times x, and I have 3 more x's because of that x cubed. I have a y and a z. On the bottom, I have this 2. Now 15 is 3 and 5. And then I have 2 z's and 3 y's because of z squared and y cubed. Now I'm able to cross off anything they have in common. So I can cross off the 2's, cross off the 3's. Let's see, it looks like I can cross off 1 z and 1 y. Now I look, what's in the numerator? Well, there's a 4 there. And there's 5 x's, so that goes back down to x to the 5th. All over 5 z to the 1st and 2 y's, so y squared, and we're done. I see example 2 is the same thing, except for that it's division. So I'm going to switch these two. So we have 3x to the 6th y z squared all over 7x y cubed times, now I'm going to flip this, so 7x to the 6th y squared z to the 6th all over 15x y cubed z to the 8th. Okay, now I'm going to expand it out so I can see how I'm going to cancel. Now, as you can see though, I'm going to do it the long way, which takes a lot longer, hence the long way, than knowing the little tricks. But I really want you to see if you can find the trick yourself. If not, it's okay. So on the top here, I have 3 times 7. Then I see I have 6 x's here and 6 x's here, which means I have 12 x's altogether. I might do this where I can save myself space. There's 8, 9, 10, 11, 12. And see my y's. I have 1 here, so don't forget that's to the first, and 2 here, so I have 3 y's. Z squared and z to the 6 would be 8 z's. On the bottom, I have 7, and then I'm going to break down that 15 to 5 and 3. I have 1x here and 1x here, so that leaves me 2 x's. 3 y's, 3 y's, so 6 y's. And 8 z's. 1, 2, 3, 4, 5, 6, 7, 8. All right, let me cancel. Well, what's great is I have 8 z's on top, 8 z's on the bottom. They're all gone. And I ignore those, right? 3 y's on top can cancel with 3 y's on the bottom. 2 x's, 2 x's, 7, and 3. Okay, let's look at the top. I'm covering this because sometimes people misplace that 5. So on top, we get 10 x's, so x to the 10th, and nothing else. And on the bottom, we have the 5, and then we have 3 y's and no z's, and we're done. Perfect. So be careful, because these definitely, this is where you expand and cross off. As you can see, as we go through the examples, now we have to factor. So I see this is multiplication. So I'm going to take each part and see if I can factor. So x plus 1 can't factor. Now what I'm going to do is put parentheses around there, knowing it's a group and they have to cancel out together. Then I have x plus 4. Then I have what's in common here, x times x plus 4. And then the x plus 2 just stays. What's in common on top and the bottom? Well, this group can cancel out with that group. So what's left over? When we have an x times an x plus 1 all over the group of x plus 2. Okay, let's go again. More factoring. Multiplication, so we don't have to flip it. But I'm going to take each part and see what I can do for factoring. So this first one here, x squared minus 4. Well, hopefully you're recognizing that as difference of squares. So that is x plus 2 times x plus minus 2, sorry. Minus 2. On the bottom there, I see, what do they have in common? They have a 2 times. Now, I'm going to factor quickly, but you take your time if you need to with your box method or your grouping. This factors out to x minus 3 times x plus 1. And on the bottom, factors out to x plus 2 times x plus 2. So again, crossing out those groups. So I have an x plus 2 that I can cross out. And then I can cross out an x plus 1. These do not cross off because one's subtraction, one's addition. So my final answer on top is x minus 2 times x minus 3 all over 2 times x plus 2. Very good. All right, 2 more examples. Now I want you to change this to a 4 because I made a mistake when typing. Okay, so do this as 4x minus 20. So this is division. What I'm going to actually do is factor around this and then flip it because I tend to like factoring to get it out of the way first. So at this numerator here, I can take out a 4, leaving x minus 5. On the bottom here, I have a trinomial. You do your box or your grouping. You should come out with x minus 7 times x plus 3. On top here, this is the difference of squares. So this is x plus 5, x minus 5. And then this trinomial, x, let's see, 5 in the middle. So that would be negative 8 times x plus 3. Again, guys, I've been doing this for years. I can do it in my head. You use your box or your grouping. Remember, this is division. So I'm going to flip the second fraction. So I have 4x minus 5 all over x minus 7 times x plus 3. Multiply and flip. So now on top is the x minus 8 times x plus 3 all over x plus 5 times x minus 5. Let me cross off. Ready? Cross off. What's in common? Whatever is left over is our answer. On the bottom is x minus 7 times x plus 5. And we're done. All right, of course, we're going to get a little bit more difficult here. Oops, sorry, guys. The light turned off. Yep. All right, I'm going to factor first. So this is x plus 3 times x plus 2. Again, do your box or your grouping. On the bottom here, what do they have in common? They have 5, leaving x minus 1. Here we have x minus 7 times x minus 1. Bottom we have x. Let's see, that would be minus 6 x plus 2. Here we have x minus 7 x plus 3. And here, be careful, okay? We have a greatest common factor of 10x, leaving x plus 4. Okay. Now, this is multiplication, so these stay. This is division, so we have to flip this. So I'm going to rewrite all of this with that flip. X minus 1 times x minus 7, x minus 1, all over x minus 6, x plus 2. And I need to flip this. So now it's multiplication. I have 10x on top, x plus 4, all over x minus 7, x minus 3, or plus 3, sorry. Now, we have a tendency that when we've been canceling, because we automatically think groups, we cancel the groups first. So let's do that. X plus 3, x plus 3. X minus 7, x minus 7. X minus 1, x minus 1. Okay, for our groups, we're good. Now, here's where most people make the mistake. So make sure you keep this in mind. We have 10x here and 5. If you remember, 10 is 5 times 2. So what else can we cross out? We can cross out that 5. So in the numerator, I'm going to put that coefficient up front there, the 2x. And then we have, oh, look, I almost forgot another group, right? There we go. Got that group. So we have x plus 4 all over x minus 6. Oops, sorry, you guys can't. Okay. Factoring is very important. You don't factor correctly, you can't cross off correctly. So be careful. Remember that division, you flip that second one. All right, now we can practice some of your work.